Welcome back. In today's video, we are breaking down the fundamentals of two-dimensional geometric morphometrics in R using the standard library geomorph. By the end of this tutorial, you will know how to import landmark data, perform generalized Procrustes superimposition, visualize shapes in morphospace, and run statistical hypothesis testing. Let's jump straight into RStudio. This is the first block. Loading libraries and data. As you can see, we start by loading the geomorph library and the built-in pupfish dataset. The pupfish data contains 56 landmarks, coordinates collected across 54 specimens. In geomorph, landmark data is typically stored as 3D or three-dimensional array where dimensions correspond to landmarks, dimensions x, y, and specimens. Now the second block is a Generalized Procrustes Analysis or GPA. Raw landmark coordinates cannot be analyzed directly because they contain positional noise, variations in orientation, scale, and translation. We call GPA gen function on our landmark array. This scales every specimen to unit centroid size, centers them, and rotates them to minimize the sum of squared distances. The output gives us our clean Procrustes coordinates, centroid sizes, and the consensus mean shape. Moving on to the next block, block 3 and block 4. PCA, the principal component analysis, and morphospace plotting. Now that our coordinates are superimposed, we conduct a principal component analysis using gm.procomp function. Because landmark datasets are high dimensional, PCA reduces them down to major axes of shape variation. We then plot PC1 against PC2 and color our points by population. This is the block 4. This gives us an immediate visual sense of whether different populations cluster separately in morphospace. Now moving on to the next block, block 5. Visualizing shape deformation using TPS, that is Thin-Plate Spline. One of the biggest strengths of geometric morphometrics is showing what the shape change actually looks like. Here we extract the consensus mean shape and use shape.prediction function, shape.predictor function to calculate the extreme shapes at the minimum and maximum of PC1 using plot ref to target function. With the Thin-Plate Spline, method is equal to TPS. Option, we see a deformation grid that illustrates the physical stretching and compression of the body shape along that principal axis. And finally, we move on to the last block of our demonstration, that is block 6, hypothesis testing, execution of Procrustes ANOVA. This is the test for sexual dimorphism and population divergence with size as a covariate. Finally, we test our biggest biological hypothesis, We package our shape coordinates, centroid size, sex and population into a geomorph.data.frame function. We then run procD.lm function, which performs a Procrustes ANOVA using residual randomization permutation procedures, or RRPP. When we run summary shape underscore model, the console prints an ANOVA table with F values, effect sizes, Z and P values. Let's run the code so that we can see our output. Here is our output. As you can see, the console prints an ANOVA table with F values, effect sizes Z and P values, these three. Looking at the output, we can evaluate whether body size or allometry, sex, that is sexual dimorphism, or population significantly drives morphological differences. Here, that's the full fundamental pipeline from raw coordinates to statistical tests in under 40 lines of code. If you find this helpful, hit like, subscribe and leave any questions in the comment below. Thank you.